Hello guys, welcome back. And in this video, we will discuss the problem on the basis of the binary search. In previously video, we have discussed the binary search, and we know that how the binary search is work. But in this question, we need to modify the binary search, and so the modified binary search will be applied in this question. So first of all, let's discuss the problem. Let's discuss the problem and then we will discuss the solution of it. Okay, so question is saying that we have given there is a array nums which are sorted in an ascending order, and we have rotated this array at some unknown index. Okay, and now when we have rotated the array, now we have given the rotated array and a target. Then we have to find out the target to our rotated array. We have to find out the index if target is present, or if it's not present, then we have to simply return the -1. So let's discuss the example, then you will understand the problem better. So let's say we have given this array. Okay, so this is rotated. Previously it was like this. Okay, 0 1 2 3 4 5 6, and it was rotated by this index. So this is rotated, and now it becomes 4 5 6 7 0 1 2, and now we have given the target 0, and now we have to find out whether 0 is present in this array or not. So in the binary search I have told that we can apply the binary search only if we have given the element in monotonically increasing fashion. So in this array, it is not the monotonically increasing fashion, but uh, let's draw the graph of this array. Uh, First element is 4, then 5, then 6, then 7. Till here, it is monotonically increasing. Okay. Now we have 0, then 1, then 2. And this is also monotonically increasing. Okay. So now our array is divided into the two array which is monotonically increasing. So how would we apply the binary search to this question? Okay, we have I and then j. Initially, when we were having the one single array which is monotonically increasing, then we get like this graph, and here I and here we have j, and mid element is lying some position in the range I and j. Okay, and it is for sure that ARR mid is definitely will be greater than ARR of I and smaller than ARR of j. Okay, uh, but here there can be the two case. One case can be where mid can be lie here also. Mid can also lie here also. So accordingly, we will have the cases. So let's discuss the case. So first of all, it is simple. If we found that ARR mid is equals to target. If it is equals to the target, then simply return mid. We have found the element and we will return the mid index. Okay, no issue in this. But we have the case number one, that if nums, or we have defined array, we have array of mid is greater than ARR of j. So what does it mean? It means that mid element is lie in the first array. How? Because if this this is the this is our array, then if and it is monotonically increasing, then we know that the element which is after the mid, which definitely will be greater than the element at the mid. But here we are checking that element at the mid is greater than element at the last. If it is, then it means that it is lying in this region. In this region, you can check these element will be greater than this element. See, these are 7, 6, 5, 4. It is all greater than the 0, 1, 2. So it is for sure that mid is lying this region. So we have to check the one more condition. We will check one more condition. Okay. Then we will check if it is true. Then we will check if target is the element that we want to search is smaller than ARR of mid and target is greater than equals to ARR of I. If it is, then we are sure that if target is somewhere here in this region, then it is for sure that the target will be smaller than uh, let's say if mid is here. Okay, then we are checking if the target is smaller than mid, so target will be left of the mid, and if target is greater than array of I, that is it is right of the starting index, then it is for sure, then we have to decrement the j to the mid minus 1, because now our range of carry will be I to mid only. Okay, so what we will do j is equals to mid minus 1. Otherwise if it is not if the target is not lying in the I to mid, then it is for sure that our 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 target will be lie after the mid somewhere here. Okay, so what will we do? We set our else in else part we will set I is equals to mid plus 1, because this condition is false, then it means that our target is lie right of the mid index. Okay, this will be the case 1. What will be the case 2? So case 2 will be if ARR mid is smaller than ARR of I. Okay, so when ARR of mid is will be smaller than ARR of I, when mid will be lie in the second region. Let me draw again here 4, 5, 6, 7, 0, 1, 2. If mid will be lie here, then only it will be smaller than array of I, that is element which is before the mid element. Okay, or it can also be lie here also, because if mid is here and I is before this, no, then mid cannot be lie here because it is increasing, so mid will always be greater than previous element. But If the mid is here and I is here, I lie here and mid is here, then only this condition can be true. ARR mid, that is this element will be smaller than this element, then only this condition can be true. So we have to check another condition. If target is greater than num or ARR mid, and target is smaller than equals to ARR of J, that is if I is lie here, that is I is lie here, mid is lie here somewhere, and we are saying the target is greater than ARR mid. Target is greater than ARR mid when target will be to the right of the mid, and we are saying target is smaller than ARR of J. So and J is here, so target will be smaller than J when it will be to the right of left of the J. So this will be the reason to check whether our target is present here or not. So our reason will be mid to J. So what we will do, we now we do not need to check the element before mid. So what we will do, we will increment our I to mid plus 1. Okay, otherwise if this is not lie, target is not lie in this region, then it is for sure the target will be lie in this region. So we need to decrease the J to the left of the mid. So we will say J is equals to mid minus 1. Okay, if these are not the case, if this condition is not true, and else if this condition is also not true, then we are left with a case number 3. That is our default case, simple binary search. Then we will check else if target is smaller than ARR of mid. If it is the case, then we will decrement the J to mid minus 1. Else I is equals to mid plus 1. Okay, and this loop will be run until I will be smaller than equals to J. This process will continue. Okay, and at last we will check, uh, or at last if we will found the target, then we will definitely return the mid here. If we do not found the target, then we will come after come through or exit the loop, and we will come here, and then we will return simply return minus 1. That is our target is not found. Okay, so these are the cases. I hope that you understood the algorithm or problem, how to approach this problem. You can write the code by your own. In the next video I will implement the code. So if you didn't get the code, then you can watch the next video.